come up with the thing that you guys read?
Yeah.
No. No? Maybe. They're going to show us what they have done in the last 2 semesters. Hopefully will be enough. You guys are, whenever you guys are ready.
All right. Hello everyone, thank you for being here. Today we are going to present our senior design project, multi-use loading system. My name is Monsef Tahri, Eduardo Rubio, Brenda Quinteros, Rigoberto Aguilera, Salwanka.
Right. Our goal as engineers is to design creative technological solutions for our barriers in society to making our day-to-day life a lot easier. So our group, in our country, last year, 30% of our population are facing obesity, and another 19% are suffering from other physical disabilities. So our group came up with an idea of creating a system that can move a person in and out of a vehicle in a very easy and comfortable way. In this case, it's going to be a minivan. So we searched into the market to see if we can find any similar ideas to ours, and we did find some at a very high price tag of $30,000 or more, all the way up to $50,000. So we asked ourselves, why was this so expensive? So after some research, we found out that what these companies do is that they sell you the vehicle itself with the system already installed. This is due because they modify the vans and their vehicles for their system to accommodate their system into the vehicle. Other companies, what they will do is they tell you to bring your own vehicle so they can modify it, so they can fit the system inside. So for the past 2 semesters, we design, build, and test our system, our multi-use loading system, to perform the same activities that these older systems do, moving a person in and out of a vehicle, like I explained. Also, with the difference that our system is universal. It works for every single type of minivan out there. You don't have to modify anything. All you have to do is clip it on the floor of the van, just like you do with your conventional car seats. And to remove it, you do the same, just clip it off. Also, if you don't want to use it to transport people, you can remove the seats of the system and then just add a flat platform to carry other types of loads, such as groceries, luggage, or heavy loads up to 700 pounds. It's 300 pounds for each seat.
After we decide what we're going to build, we start with building prototype using wood. As you all can see in this picture, we have a prototype built with wood, a scale of 1:5. We use a link arm that we were thinking to put a hydraulic piston to drive that system in and out of the vehicle using the 2 support wheels, as you guys see. But after that, after testing it out, the link arm did not fit inside the minivan, and it also required a lot of power to operate. So we move in to replace that with a sliding mechanism, and also to remove the supporting wheels because they were unstable. Also, our third prototype was built with the 1 scale measurement using PVC and wood and a railing system. We did test it out in a minivan to see if it will fit. Also, it will not touch any of the vehicle components. And here we have a prototype 3D drawing that we use CAD software just to first design it with a chair and with the sliding mechanism.
Now, this is a 3D drawing for our mechanism, and it's based on all major components for our design. The applied material was carbon steel A36, and this drawing was utilized to perform our final elements analysis. Based on gathered information, each bracket, each seat, vehicle seat bracket has impact capacity load of a static load of 1,200 pound force, and also each of the brackets, each of the floor hooks where the brackets clip, it has a static load of capacity of 1,200 pound force as well. Now, we performed several tests on our design with different loads at different locations. This is one of the tests that we performed where we had 350 pounds on each car seat. And that was applied while the system was outside approximately 25 inches from the minivan door. And the maximum stress, effective stress came out to be 7 KSI. Now for carbon steel, the yield point, it's 36 KSI, which this means that our system is not close to the material's yielding point. With the same note applied, we perform more analysis. We'll perform more analysis to check how our system will behave, and based on the results, there were no deflection, plastic displacements, bending, or permanent deformations. Now, we also took into consideration safety factor with the same applied load. And in this case, our safety factor based on the FAA analysis came out to be 5.
How much?
5.
Now, for our final design, we decided to go with a roller rail system. As you can see, there's 20 cam followers with a static load of 3,000 and a dynamic load of 2,200. And we have a DC motor in the center. Now, the DC motor has a 36-to-1 gear ratio. It has a 183 inch-pounds of torque, 6-inch sprocket with a 5/8 bore. And we incorporated it with a industry chain size of 40. Now, in order to, oh no, this is sliding mechanism. No, go ahead. For the sliding mechanism, we have 2 options. The first option is for the seats. So the people that have disability can be introduced into the seat. The seat turns 90 degrees this way, 90 degrees back, and then bring them in. Or you can put a platform where it comes in and out. And in order to control this, we use a circuit with the Arduino and an IBT motor driver, and the enclosures on the right side. And the Arduino is a pin input output. So whatever it is you want to use, like let's say you want to use a switch or an output that such as a motor or LED, well, you program the Arduino. You could use like a simplified version of C or C++ language, and you put in your own coding, and it'll do what it is that you need it to do. In this case, we needed it to control a motor driver, to control the DC motor, and it sends a PWM signal to the motor driver, which is a pulse width modulation signal, which will either make the motor go fast or make the motor go slow. Our motor was going at 50 RPM, so we needed to reduce that, because if we didn't, it would just zoom right out. And it happened a couple of times. And so we reduced it to, well, there's a range between 1 and 255. So we went down to 33, which is like almost 6 RPM. And that's how we were able to control it. And the IBT2 is also an H bridge, which allows it to reverse the polarity. So we could go forward or reverse. And that's about it for that. Now, in order to control it, we use an RF remote control 4-button. And I think 15 megahertz receiver, which is momentary. So when you click the button, it's just going to click that one time. But if you decide to hold on to the button, it'll keep sending the signal. And that's how we were able to control the motor. We were able to stop, go, reverse, forward with that. Now, in the next slide, we realized there was some issues with the remote, because if it was accidentally in your pocket and you sit down, you could actually press the remote and the thing will start moving forward or back. So we added the Pizer buzzer, and what that does is, as soon as the system is activated, it starts buzzing, so you know it's going off. And the micro switch on the right side is used as a safety factor. So in case it does go off and you're not aware and you can't stop the remote, this lever will hit, or another lever on the other side would hit, and it'll automatically stop the system from moving.
Now, for our mechanism installation, we started with the original minivan as it comes with the original seats. Then we went go ahead and remove the seats, exposing the floor hooks. And then the next step was to go ahead and install our system. That's our system. There's a closer look of the brackets installed into the floor, into the minivan floor hooks. And that's our system on top of the brackets. And that's our system already installed, including the passenger seats.
And here we did some testing, as you all can see. Sitting, hanging in there, taking the rest for the testing. We did the testing outside to see first how it would operate, and it did move forward and backward. Then we went ahead and we did a short video. It shows how the seat moves out and moves back in using a remote control, as my friend said. It's also facilitated to put a person or a car seat with a child and to bring it in. As my friend said, that our system is multi-use. It can be used for carrying a luggage, boxes, groceries, any type of loading. It also moves to the right and to the left side using a remote control, and it also facilitates and help you carry any type of load.
Sorry about the background noise.
For cost analysis, we compare the total cost to fabricate 1 unit and the total cost to fabricate 1,000 units. The cost for single production is $1,452 per unit, and the cost for mass production is $1,016 per unit. With the understanding that most startup companies deal with warranty from 0.5% to 3.5% and marketing costs from 8% to 20%, we consider value between those ranges. In our cost analysis, we evaluated markup from 10% to 7%. With all those assumptions in mind, we consider two cases. The first case deals with 30% markup, 1.5% warranty, 14% marketing cost. And the return value for that specific case came out to be $1,887. And its profit will be $473,000. The second case deals with 50% markup, 0.5% warranty, 8% marketing cost. And its retail value came out to be $2,178, and its profit is $870,000. In conclusion, our goal was to design, build, and test a system that will help disabled people have easy access into a Minivan. 836 steel was the most adequate material for us to use because it was inexpensive and have better material properties. Our system is in compliance with the standard of the U.S. Department of Transportation and the National Highway Traffic Safety Administration.
For future recommendation, we consider some other feature. We're planning to put a rating system that can move our system backward and forward, inside the minivan. And also, instead of operating the seat physically or manually, we're planning to put them operate or swivel automatically. For the third feature, we're trying to modify the seats to make them a little bit shorter for easy access. And thank you. Any questions?
Quick one. I didn't see the photo of you inside the minivan on top of the chair. Do you have enough space?
Yes, we do have enough space.
Because
And what's my head is right in there.
Yeah, good presentation, guys. Thank you very much for that.
Thank you.
So, I do have some big concerns about the material. Okay. First question, though, before we get into the material is, was there any vibration analysis done on this? Because we know, cars have a tendency to vibrate. And what's keeping this thing from being damped, if you will, right? Because things are going to pop loose.
Actually, our system is a sandwich between a seat and a seat bracket.
Okay.
So if the seats are in compliance with doing more testing, as you say, vibration, so we just kind of sandwich the system between the seat bracket and the seats. So we did not do any vibration testing, but I believe it is approved since the seats are already approved for vibration.
Okay, yeah, because it's going to vibrate, right? And without an analysis, you really don't know what your frequencies are. Yeah. So, and where I'm getting with this is the 836 material, right? A ferritic material, has a tendency to absorb frequencies quite a bit rather than dissipate. So, and there's another major characteristic that 836 is very notorious for. It is high in strength, so That was a good selection for that. However, do you guys know what one of the major downsides is with A36?
The major what?
One of the
Downsides.
major
Downsides.
detriments to A30. What does it do? You guys know what A36 does when it's exposed to air? It rusts. It rusts, it oxidizes, right. So I didn't see any coating on that, so that's gonna rust pretty quick, especially in our environment.
Yeah.
But it is a high strength material, but it has to be coated, and I didn't see any technical analysis on any type.
Well, that's
Oh,
one
the
of the
system was
features.
primed and painted? Okay, okay. What kind of coating did you use?
Oh, we just used for the primer, we used the red primer from Home Depot.
Okay.
And then normal acrylic enamel paint.
Okay, because that stuff chips pretty easily, right? It's not meant for just like typical corrosion, if you will. So you know, probably like a magnetic coating bait process would have been great. Back on the metal. So you guys had a slide mechanism in one of the first slides, and you guys got metal to metal contact. Did you guys do any calculations on how long that's going to last, the wear life?
We have
Yes.
cam follower,
Okay.
which is it facilitates the sliding thing, and this can hold a static load for up to 3,000 pounds.
Okay.
And it's also they are lubricated from inside.
Okay. What kind of lubrication did you guys decide?
Well, the lubrication comes with the cam follower.
Oh, is it an off-the-shelf mechanism?
Yeah, it's a lifetime
Oh, okay.
seal, so there's no need to.
Okay. I apologize.
Yes,
I
there
thought it
is
was
no need
something
to.
that you guys designed. So.
No.
Okay.
No, the camera followers, we just installed those.
Okay.
1 inch.
I'll let ask a question. I got one, but I'll wait.
Yeah, let's see. I've got a couple. First of all, have you considered the question? Well, I think somebody asked about whether you had, whether there's a picture of someone sitting in the thing as it's going back and forth. But my biggest concern about this, when I see you sliding someone in and out, is pinching. Somebody getting caught in there, a limb, a piece of clothing. That's my biggest concern. I didn't really see a lot of discussion on that. So that's when I see something like that, my biggest concern is somebody getting either somebody's a limb, their hair, their clothing, anything dangling, that kind of thing.
That's why we have the buzzer, so it's alert whenever it operates, it's gonna sound the system. The buzzer will go off, so it will tell you, hey, the system is operating.
But do you
So
mean
nobody should need
The system is operated by somebody that's used to the vehicle, so when they're installing or when they're putting their load, or let's say a person that's disabled, their job would be to look out for that. No. So, I mean, that's their job. I mean, it's not like a one person, you go in yourself and go in. It's a 2-person job where the second person is taking care of that person.
The comparable system that I think of is like a minivan door. If I have my arm in the minivan door and I hit the close button, what it'll do is it'll close, it'll stop on my arm. It has a sensor there, it does not crush my arm, and it will go back out without causing any damage to my arm.
We have sensors.
that's what it does? That's exactly
Yes.
what it does.
It does have something like that?
Exactly.
Like for example, this will not keep going if the door is closed. Like there's a sensor here. There's also 2 sensors in here.
As long as it touches, when it touches the door, it stops automatically.
But you have like a force sensor that if there's something blocking, or it's just if it detects a door. I mean,
If it hit the door, it will shut automatically.
Yeah, it would stop.
So we have
You mean
4
like a
sensors.
garage door sensor where if it senses
no, just
something
anything.
underneath?
It could be the door. It could be anything.
Anything that gets on its way as it's going out, it will stop.
Okay.
Either this way or that way. There's, like I said, there's 1 sensor here,
Yeah,
1
there is.
sensor there, and 2 sensors there. So those 2
See this
sensors will
lever
do
right
that
here?
job if there's
There's
anything in the
sensor,
middle.
And there is 2 sensors on the back,
In the back as
in
well.
here, and another sensor in here. And we can add more in the front as well, or we can add them on the seat as well.
Were these
Part of
opti-
the,
oh, I'm
as a
sorry.
clarification, sorry,
Mhm.
and I think you guys haven't, whenever somebody's asking, just pay a little bit of attention. But something is, for example, if the thing is outside,
Mhm.
and the thing is getting retracted inside, you're already twisted, and by any chance, a leg or anything from the person that is here, you activate it, and you're trying to find the thing, meanwhile you're trying to find your click, this thing is retracted.
It will stop.
Right? It will
stop
it will
these
stop
sensors?
if your leg is outside and it feels that you're
Yeah, all you have to do is just you touch it, and the system will stop completely.
no.
Oh, so the person needs to know to press that lever though.
To-
No.
They would. That would be like a kill switch that automatically stops the system from moving at all.
Okay.
You can
I
add,
need to know that.
yeah, because the other person, if it starts moving, and the person wants it to stop, the other person that's helping, you can just touch it, and that's it. It will stop the whole system.
So maybe something that it was pointed out before by David in some of the presentations, a good thing to have is always a kill switch. You know, really indicated on site, so whatever happens, you just press that button.
Well, I would like to see that like painted red and some sort of, you know, because I don't know what that
That's the
is.
thing is, it's
You can
no,
come
it-
around and
consider
see
that.
it, I mean, it's,
Yeah, but I
it's
mean,
there.
it's just a black lever though. You don't know,
Yeah.
there's nothing to indicate that this is
And also,
the
we have
Yeah, you're right,
buttons
yeah.
in here
Labeling.
that you can
They
stop
loading,
it
yeah.
when it's operating.
Did you guys, were these off-the-shelf sensors you bought, or did you guys actually?
Oh, they're just
program
micro
it?
switches to
Micro switches?
Yeah.
Okay.
and it either kills the circuit or leaves the circuit open for it to operate.
Okay, did you guys do like a control process on that? Like, did you use any equations to understand your timing on that, or?
Oh no, the timing is rather rapid. As soon as the button hits it, it kills the circuit automatic. There's no delay in the time.
Okay.
So you have a microcontroller, an Arduino microcontroller in there and all that. I didn't see in your presentation how you had wired it up, because they're asking questions and it's coming out to like, we're missing some sort of diagram that would tell us where all the sensors were and stuff. And then you have a radio transmitter, but the board you showed doesn't hook up to the Arduino necessarily, right? So how did you hook that up?
Yes, if you can go back to the picture.
Yeah, go
like
back
show-
to that. I was curious about that because it didn't look like a shield that would go over the Arduino, right?
Okay.
See working?
So
Okay,
my
well, the
question
micro
is-
switches, they're all connected in series.
And they're all connected on
to one pin. So, and the pin has a pull down relay that'll automatically stops the voltage, because for the Arduino you need, it's either a high or a low. So with these, it gives it a signal of low and it turns off the system. Right here is the RF receiver right here, and the pins for 1, 2, 3, and 4 are connected to between 4 and 7 right there. And what was the thing you had asked? Sorry.
Yeah, so then this isn't bad, a wiring diagram or something, so that we know where all the sensors, you know, like an exploded diagram
Yeah,
of the sensors,
Yes.
if that makes sense.
Yes, I understand. No, I didn't make a diagram like that for it.
Okay.
So let's say you wanted to make it again, and let's say this one got broke, you would have to start from scratch, right?
Yes.
Okay.
Can we see this in working condition?
Yeah, we can plug it in.
Yeah.
Where's it at?
And plug the.
Right now, the system is a little bit unbalanced on the
Because it's sitting on the dolly.
Yeah, let's
So
put it
we
on the
need
floor.
to- No,
No, it
it's
can
fine.
still work,
But
right?
let's just keep an eye on that.
Now, so for the, I'll demonstrate first in case it accidentally goes off in your pocket, the buzzer goes off. So let's say it's in your pocket, it's gonna go off. Oh, hold on, the hotel.
Yeah, we have a safety.
Yeah, so the system won't move in case you decide to.
Alright.
Now this thing right here will automatically kill it. There's another one back there that will automatically kill it. And on that side also that will kill it. And then to go back,
So both of
By
them.
pressing this, it will touch it.
So now can
go ahead,
you
you can touch it.
Can you what?
can you swivel the?
Yeah.
Yeah, manually.
Well, hold on, I gotta put it back.
Oh, it's good.
Oh, you can do it on that side.
So it is at that height, right? We are
Yes,
talking
yes.
about minivan. So
Yeah.
how does a disabled person get
Well,
on?
our system is not a self-use.
It's for a transporter of people that have disabilities that can't transport themselves. So let's say somebody in a wheelchair that can't move.
somebody has to.
Somebody has to
Take
manually
him
pick
and
him
put
up,
him-
put him in the system, and watch him while he's in the system to make sure everything is okay.
Yeah, but
So
that
it
would
will
be.
not work for the disabled driver.
No.
No,
But
this is for a person
The
that's,
past second.
that maybe his job is to move disabled people from one place to another.
Okay.
And it's also, you know how difficult to put a person inside the car. Let's say that you have a child and you have to carry. And that hassle to go to put yourself halfway inside the car and put that child, this system will make it easier. If you bring the chair outside, just place it in, pick it up, swivel it back and load it.
So why don't you separate these two? Why both of them has to move? You can just separate them.
Well, you can separate them, but you need to have two motors to drive each one.
A bit more
Is that-
expensive
is
too,
that difficult?
budget wise.
It's not difficult, it's just cost.
Yeah, it's
Yeah.
just cost
Okay.
because of cost reasons, yeah.
Yeah,
And
so
also, as we
price.
say, it's multi-use, and basically, we have it here.
When you remove the two seats and add like a
You can
platform,
remove the seat, place this on top, as it shows in here. And there will be a flat bench, you can put anything on top of it and facilitate to load.
like I was saying,
About the safety belt, will you consider it in the future apply this safety belt system? Safety belt,
Safety belt?
yeah, for this person,
Oh, safety belt?
yeah.
Yeah, you can put like a 2-point safety belt, and also we keep using the
the
Minivan.
same band,
Same band.
safety
Because
belt
we
as
keep
well.
the same chair, and they have the
Same
seat
thing.
the seat belts in here.
Like a booster seat.
Like a booster
No, but when the
seat,
person
correct.
is out, he has to be the seat for the seat, the seat belt for the seat.
Like I was saying the other day when we did the mock exam, by coincidence, I was walking into the school and there was actually in front of the school a disabled person with a wheelchair outside. And I saw a gentleman going inside the car, grabbing the person, lifting him up, and then put him in the wheelchair. I think with this system it will be a lot easier. Just bring them outside and then just drop them into the wheelchair. It will be very simple. But yeah.
Can we go to the FEA analysis, please? Yeah, that one's fine. So, what was your weight on that, on the system, the frame itself right there? What was your base weight?
The weight on the system by itself?
Just that right there.
It's 180 pounds, that's how much the system weighs.
Okay, so you said you had a safety factor of 5, right? So was there a reason to keep it that high?
No, our safety factor is different more from load to end load. For
Okay.
that particular load, 350 pounds, it's come out to be 5.
Okay, but is there a reason that why you wouldn't kind of minimize that? Because you're still not even close to.
You can actually put more load. We did some more testing up to
Right.
1,000
Okay.
pounds on each seat, and they come out to be about 2 for safety factor. The only thing, if you put 1 pound on each seat, that would be 2,000 pounds.
Right.
I don't think the vehicle will carry 2,000 pounds.
No, that's kind of where I'm going at with this. So, by adding a couple stiffening members and even switching to a lighter, cheaper material, you can optimize the design.
Yeah,
right?
you can optimize the max
So the
load.
safety factor is a little high.
Yes.
Yeah, and it's heavy material.
Yeah,
It's
it
strong,
is.
but it's very heavy.
Mhm.
That's right.
Yeah. So
We tried we looked into like aluminum, for example, but it's almost double the price.
And also
So it's gonna
stainless
go
steel as
over
well.
the wall, yeah.
Okay. So, very well. What was your, something I didn't see, a Gantt chart or any type of schedule. What's your turnaround time on to make one of those from scratch?
How long it will take to build it?
Yeah.
I would say it will take about a month to build it.
Working every day, a few hours a day.
What would be what's your biggest challenge with making this?
The biggest challenge is designing the channel and finding out about the bearings.
So
If
you're
you,
saying
if you already have the design and you're gonna put it together like what he's saying.
Oh,
how
probably
long
less than a
will it
week.
Yeah.
Yeah, less than a week.
Okay.
I think the biggest challenge we had is the measurements. with the vehicle, trying to like make it so we not hit any vehicle parts like the door or the front seats.
So it'd be
Trying to make it as more
customizable?
comfortable as possible.
Yeah, so
So
it's
you-
customizable.
Putting it together will be short, but it's a matter of time with getting the parts on time
Yeah.
also.
So how does it mount to the vehicle? I don't remember seeing
It
any
just
like
clips
assembly.
into the hooks.
This
all
over here, this hooks,
Uh-huh.
these are the same exact brackets from car seats.
Okay.
So this just it just clips. Shows
Yeah, we
right
had it
here.
in one of the slides.
So is it the same clips that you have, the same brackets that you have in your regular car seats?
Mhm.
And if, there you go.
What's your most critical component on that frame?
The joint that hooks onto the car.
Mhm.
That's where the biggest stress would lie when we did our stress analysis. That was another reason we couldn't do more than 1,000 pounds, because that joint right there would be the first thing to fracture or
Because that's sensitive.
permanently
so
deformed.
you don't be-
Permanently deformed, okay. Okay.
Couple questions. On your strength analysis, what kind of loads and how did you handle the design for? What about something like crashes, collisions? What kind of loads are going to be on your frame in the event of a vehicle collision?
Well, since we're using the same seat bracket, and they have a static load collision impact of 1,200 pounds, and each hook has that amount of impact, static load.
But that's a vertical load, right?
That's a vertical load.
But what direction does a impact generate load?
Forward. But if the seat is outside, I don't think it would be.
Well, it's not going to. I'm not talking about the kids. Obviously, not going to be.
When it's inside the vehicle moving. it's
Yeah.
an
What
accident.
kind of? How do you? This is the kind of thing you need to think about in terms of your strength design, because everything that goes into a vehicle needs to be rated for everything that vehicle experiences, including crashes. So if you were going to actually market that, you probably want to start, crash testing it and things like that. And so you need to think about what kind of. I saw you do purely vertical load testing, but when you actually design something like that, you would have to do horizontal dynamic loading on that, because that's the kind of forces that actually appear in impact.
Well, we could do that if we have a real dummy, and we can spend some money.
Well, I can volunteer for that.
We can do like a dynamic testing to see for the collision. I don't think I would take the risk as a bit important.
It is a big question.
Yeah, I would have, I think more than a question, maybe a comment, because I'm still a little bit concerned with the height that you add to the seat, no? And what I'm not seeing in this presentation again is it's a real person. One of you just for the photo, just to see.
Yeah, we sit, as I say, I sit on it when in the van. My head was like scratching in the frame underneath.
The frame outside,
Yes,
because then
The top door.
not the
On
roof,
here.
not the ceiling, but the frame.
Yeah,
Yes.
that is
so
Yes,
like
and
it's
the-
5'10", so it's
And that's
tall.
why we took into consideration modifying the car seats
Okay,
as well. for
Yeah, because
future
what I'm
recommendation.
thinking is that I'm thinking in a full grown-up handicapped person. So not a child, which they have room for that. So I think the presentation is lacking that, which is crucial for me. I mean, for what you are showing, even a video, if you trust your design, a video of some of you going and moving, and also just also like a little comment again, thinking that it's a full grown-up handicapped person, you are adding 7 to 10 inches to the height. And it's very nice to have it outside, because that will facilitate somehow the work of the person.
Sitting in the.
Yes, the one who actually have to sit. But what if I'm putting somebody 200 pounds? So
we could put a person to up to 300 pounds. You're concerned about the height.
the system, yes, but the person, the second person, the helper, the one who is going to
Lift
lift
that person
and put
place
that.
it.
So eventually also.
It will be a high, but as I say, for future recommendation, you see how thick is that cushion?
Mhm.
So if we customize or like cut the cushion or put another seat with a thinner cushion, it will bring the height down,
Mhm.
and that will facilitate more. and that person will not have to worry about touching his head by the front.
So this one can, I mean, you will have to have like on top of the system a specially designed seat.
Yes, but we keep the original seats.
This is the exact
Because
original
of
seats
the
from
I
the
mean,
vehicle.
to lower the cost.
Yes.
And along that height line, you said you're 5'8", right?
6'2".
So you're 6'2", you said? Oh, okay. And you were just barely scraping the top of it?
Barely, huh?
My hair was.
Okay, that makes a little more sense. Okay, I thought you were saying you're 5'8", and if you're 5'8" and you're scraping the top of it, I mean,
Yeah.
average male height is so and so. I mean, okay, so what is the maximum height of someone who would sit in that thing, as is?
As it is right now?
As it is.
Less than 6.
Probably.
5'10"? So you think that could comfortably sit in that as 5'10"? So again, average, if I look at my statistics right, the average male height is between 5'7" and 5'8". So you're probably excluding a quarter of the male population if you say the maximum height is 5'10". That's
With
that's
this
not,
seats.
Well, I think
With
we're
this
excluding more
with this
because it's
seats.
really for people that are disabled.
well, that doesn't change their height.
That one chop the height.
So, yeah.
And it's shorter.
So,
But
keep that in mind.
that average stays with these seats. If you customize the vehicle seats, it will be at a higher range. He will sit there perfect without scratching his head.
No, as a general recommendation, and I want you guys to absorb the questions
Yeah.
on a constructive way. If I bring somebody that is trying a water pump, and we don't see water, and we don't see it pumping water, and we don't see anything, what's the real appreciation? The thing doesn't work. So even though we see it, we see the pump, we see the things, and we don't see it working, and we don't see it going in and out with a person, it gives a sense of, well, maybe it wasn't adjusted right. If there was one image of receive going in and out and rotating, and to see the how facilitated, because you guys are doing everything except the actual it's like if I show the bicycle but I never show it riding. So those kind of things are extremely important to show the overall approach. Any other question? Thank you, Brooke.
Thank you very much, and I would like to thank Mr. Garcia. He has been our best professor.